Cool. I could see a couple of messages on the chat box. Great. Let's get it started. Good. Recent developments in EV and also the blast in EV cells. Okay, great. That's a nice, interesting starting question. Great. It's just, by the way, we're waiting for some more people to join in for this session. So we're trying to interact in the meantime. So to understand, what interests you to take part in this webinar. So over to you. So please use this chat box and drop us your questions. And hi, everyone. By the way, thanks a lot for joining in. Good to see the good number of participants joining in for the session. Okay, so there is another input. Sahil, can we use alternator in EV to recharge batteries while running? Okay, interesting question. So yeah, just tell you that it's the basic physics, the fundamentals of physics. You can only convert an energy from one form to another form, right? So it's not a perpetual motion machine that you keep an alternator and it generates an energy and then you feed it back to the battery. So it's not the way it works. So yeah, there are scenarios you could use regenerate braking in conditions, but not that you can keep an alternator and that would run in place. So which best BMS passive method? All right. Anand, maybe you can just let me know the question in detail. I should be able to come back to you. Awesome. So let's get it started. I think it's 5:33, so we're good to start. Hi, everyone. By the way, all right, so I see some more interesting. I see some more questions here. Let me start the recording as well, so in case it is required. Hi, everyone. Good evening. This is Suraj from Decibels Lab. I'm the co-founder and CEO at Decibels Lab. I also take care of onboarding all the courses that happens at Decibels Lab. So I am the course director. As a part of the today webinar, we are here to discuss about the possible career opportunities to kickstart your career in battery management systems. And this is a very hot topic today, right? So a lot of people are interested to start the career. It's like, machine learning and AI and computer science. So in the areas of batteries and electrification. So the BMS is like a hot topic and everybody want to build your career in battery management systems. Or at least a lot of people are anticipating to build a career in battery management systems. Right, so I believe that's the interest you all have to attend this session. So the whole of this discussions, I will possibly give you a direction on what you should be having as a skill set, or I would say, what is a product development cycle for the battery management system, all right? And then where you could possibly fit yourself, and then to fit yourself there, so what kind of skill sets that you need to have, right? So that is the overall objective of this, of this webinar. There won't be much like a presentation that I would just, walk you through as usual ways. I'll try to take you through some places where on the web that you could see what kind of skill sets are in demand, right? And then I would just give you a run through on the preparations that are required for it and how we can help you to make those preparations happen. Cool. So to get you started, so let me just switch myself into the other screen, and there you could see, I would say, the job opportunities that are there for EV, right? So we will go back here to get it started. Cool. So I have some job profiles, all right? So those job profiles are the ones, which are currently available in the market. Cool. So I got you some, job profiles which are here. Which is, to start with, there was a job posting from Lucas TVS, all right, maybe about like a month back, and they're looking for an engineer. Definitely for a team lead position. But I'm just kind of giving you expectations that they have for this job role, all right. So to get you started on this, I would just put a basic foundation on the journey of battery management system. If you take any battery management system, right, there are multiple sides to make the product. So one is the hardware, which you can just see in the, like, let's say something like type it out here for you. So it's basically the hardware, right? So which is on top of the hardware where all the components would sit. So if you take this as a hardware, so there are a lot of engineers who take care in designing and developing this hardware, right? So it consists primarily of the controller, which kind of keeps all the information within itself to perform any computations and to send any information, to receive any information and stuff like that. So when we say an algorithm, so the possibility the algorithm will go and sit in any of these microcontrollers, right? So something, they can be supplied by TI, it can be supplied by NXP, Infineon, ST, or various these suppliers, right? So if you kind of see this image right here, so this is like where you have a lot of components. So basically, this is called as an embedded hardware, right? So where the engineers are involved in designing the whole hardware, that could be like your power management circuitry within the hardware. So you supply, let's say, 48 volt to the battery management system, but your microcontroller only takes about 5 volts or 3.3 volts. So you need to step down that voltage to supply that to a microcontroller, right? You need any reference voltages to compare certain values and stuff like that. You kind of have to take care of all the other circuits, such as data is coming into the battery management system, such as voltage, such as current, and stuff like that. And then you have actuator circuits, like you find a short circuit and you want to shut down the circuitry by turning on the MOSFETs and IGBTs, or you kind of take care of cell balancing by performing draining the energy from the cells to a resistor. So a lot of these things, which involves intensive amount of calculations, selection of right components, integrating them properly, putting your power electronics right into a place. So that's what an embedded hardware engineer does, right? So he takes care or she takes care of performing all these activities. Again, in embedded hardware, so you would have guys working on only schematic development, then the guys working on artwork, right, who take care of putting out all the tracks and arranging the different layers, ensuring that all the components are in compliances to specific standards, and you don't have any issues on the circuit at the end of the day, right? So that's what an embedded hardware is all about. So it's about selection of right components, putting them into a right architecture, and then getting them into a design phase, and then getting into a production in place. And apart from these things, people are also there to take care of architecture of the battery management system, right? Let's say you're developing something like BMS for bus architecture, right? So, or a BMS for a cycle architecture, right? There are different things in place. So when you build a BMS for a bus, right, large size bus, so you have large number of battery modules, right? So each of those modules cannot be connected to a single battery management system. So they need to be a different architecture, right? So you could have like slave and master architecture, right? So there are multiple slaves sending you a data to the master, and then you're computing the data over there. So that's where also some level of architecture will come into a picture, that how do you put your system in place? How do you communicate between each system and system? And a lot of these things will also come. So there's a lot of information on data communications and stuff like that. So that happens on the hardware side of the battery management system, right? So then there's another side of the battery management system, which you can call it as a BMS algorithms as a core of it, right? So as a part of the battery management algorithms, right? So where we talk about something like SOC estimation, right? We talk about SOH estimation or SOP estimation or SOE estimation, right? Algorithms for cell balancing. This is the core of algorithms. They just sit inside a microcontroller, and those are the very, very important algorithms because they define the best of what your BMS does. So what I meant to tell you is, so let's say you have like a state diagram like this, right? So you need to ensure that a lot of these are converted into algorithms. So at a very core level, so there are various different methods to perform estimations, right? So if you want to estimate an SOC, there is a various different methods in place. So what engineers does at an algorithm side is they develop algorithms and they test the cells and they conduct algorithm to a real-time validation, so that they see if the algorithm is predicting something that you're expecting it to be predicted as it is in the real-time condition, right? So it's basically a set of embedded programming, but it's just not embedded software, but you need to have a logical system behind it, right? So that is where a lot of state-of-art tech and a lot of patents, R&Ds are going into a place, right? So what exactly you're trying to do is you're trying to sort of predict what is going to happen inside a cell, let's say after 1 year, correct? After, let's say, 2 years in place. The cell is same, right? But your BMS is trying to predict its behavior over, let's say, a year in place or 2 year in place. But the idea here is you have to write an algorithm which could predict the state of the battery by considering its degradation losses, or possibly by considering its capacity fading, power fading, or any changes in the chemical or mechanical structure of the whole cell. You have to predict its future behavior, right? So that is where a lot of algorithm things goes up, and then we write algorithms to predict the cell behavior, right? So people use tools like MATLAB, people use tools like Altair, or various different toolboxes are available even from GT Suite. So engineers uses this toolboxes, and then they build the models, and then you can convert those models into a C programming, right? So if you have a toolbox like MATLAB or Altair, other toolboxes in place, so you could use MATLAB or Altair to model the algorithms. There is things like Thevenin circuit, or RINT approach, or PNGV, or Kalman filter based, neural network based. So many algorithms are there. You make them in the toolboxes, and you make the tool to convert that into a programming, right? And then you put a programming flash the programming into a hardware. Cool. So that is where the job of an algorithm engineer lies. Then once the algorithms are put into a place, you need to perform a lot of testing, a lot of validation to check if these algorithms are correct, right? So that is where a lot of testing and validation comes into a picture. So today, as in simulation, we perform a lot of virtual validation, right? So we don't use real hardware, but we use a computer as a system to perform this, the validation. Give me just a second here. I'll just take a bit of water and come back to you. So any questions you have here? So we could just quickly, chat upon this. Any questions from anyone until now? So we could just take across any other questions. Anybody have any questions? Vinayak, do you see any questions in place on the chat box?
Nope.
Okay. Well, I think I might have lost the control panel. I'm just trying to find it. So, cool, no problem. I think you're able to see my screen, Vinayak. It's all good, right?
It's good. It's good. You can press escape to get the controls.
All right. Cool. So let's get back. Yeah, I was able to get that. Thank you. So if I was just walking you through the journey of development, so we started with the hardware, then we jumped into algorithms, right? So now I was talking about validation. So what we do in validation, so let's say, so we could use some things like this, where you could have a hill setup, right? So where you could actually mimic the real-time condition of the battery management system using a hill box, right? So, or else this comes in the last stage of the product development. But you can also perform something like first is mill, that is like model in the loop, right? The second is SIL, that would be software in the loop, and then you could perform PIL, that is processor in the loop, and then you can go for a HIL, that is hardware in the loop. Basically, what we're trying to do is you're trying to check the algorithm that you've developed is really going to work in A, B, C, D, E, F, G, H conditions, right? You define specific test cases, and you take those test cases, and then you try to run those test cases, see if your algorithms are right, and then it could be functionality testing, it could be performance testing, or various different type of tests can be conducted on the for the hardware. So end of the day, you're trying to basically validate what is in your software is going to work, or sometime even with the real hardware, that whether your real hardware is going to work, are there going to be any challenges in terms of memory overflow, or any such scenarios can be tested over it. It's basically that end of the day, whatever you're putting onto the vehicle has to be properly functioning in any given complex scenarios, right? That's the objective of validation. So then comes the areas of getting the real hardware done, getting the algorithm done, and then once you have algorithm, so you need also your firmwares, right? So basically, you want to make your algorithm to interact with your real hardware, right? So you need to put a lot of your memory mapping and stuff like that. That's where a lot of firmware engineering comes into a picture. So they could, if you are using a CAN, so you need to make your drivers to be there rightly, so that your CAN would communicate with your microcontroller, the data would transfer to happen rightly. Or if you have any other type of communication protocols, or you have anything else to be worked onto your hardware, you need to have your firmware layer. On top of it, you can build your application layer. So there's a lot of activities in the firmware engineering as well in the areas of embedded systems. So once on top of all these things are done, so you have your hardware, you have firmware, you have your software, which is algorithms. You put all of them with burning into a controller. Then you put that BMS onto a real hardware, real battery pack and stuff like that, right? So that is where also a lot of integration engineering happens. Then there is also the scope for calibration, because whatever we do in lab, it could be trusted to a really great extent, but it cannot go above some limitations of a lab as well. So there are a lot of real-time conditions that you collect the data from the battery management system. And then this battery management system, you would have to perform a lot of calibration, right? So that's, you could see also with IC engines that you could get an update for your ECU, right? You can get an update for your, nowadays a trendy thing is over-the-air technology, right? OTA. So what exactly it happens is where you will be able to basically push the data into a, you can connect your system to the cloud, so you could update your software just on the top of the internet, right? So here also that's a similarity is in place, that you collect a lot of data, and then you want your calibration engineers to perform a lot of iterations and then put it into a process in place of production, so that the next software which comes out will have all the bugs fixed in it. Or then you take another example where if you would have to work on the other side of the system, so where there is a requirement of application engineering, that let's say you have developed algorithms for a specific cell, everything is working, so now you have to change their application into a different one. There's a lot of application engineering. Or then if there's a product in European market and that's going to enter into an Indian market, so again, there are a lot of changes that's supposed to happen inside the battery management system with respect to its calibration requirements. So that kind of a changes which you perform there as a calibration engineer, or also as an application engineer. So if I kind of walk you through the whole journey, so you can think about an hardware, then you can talk about algorithms, then you talk about firmware, then you talk about calibration engineer, also an application engineer to find the product application in various different new role of products in place. If I walked you through the whole journey, so I would like to hear back from you now that if you have any questions about the battery management system product development journey. So I would be glad to take your questions and try to start the second part of the session. So anybody have any questions? So, okay. Interesting. What is the role of mechanical engineers in battery management systems? Great. So yeah, obviously embedded hardware is something you can't um, definitely do. I'm just going to bring up some images here so you can see through the images. All right. So basically, if you are to write algorithms, and that is where there's a lot of scope for engineers, who are from the background of mechanical engineering and stuff like that. So basically, algorithm is a software where it could tell you the condition of the battery over, let's say, X number of times. But if it has to predict that, you have to know the way the cell behaves, right? So it's where you have to basically perform a lot of tests like this, correct? The cell level tests, and then if you have a battery pack, the pack level tests and stuff like that. So where you collect the data of the cell and its behavior, and then you write your algorithms, correct? So coming to the point of that, so there's a lot of scope for mechanical engineers to explore the career in testing and collecting the data, and also creating that data into a meaningful model, and then writing those models to make them into a program. So you don't need to know like software engineering, like an embedded C to write make your models in MATLAB, right? That's like a logical based system, right? So you start with cell testing, characterization, understand the cell, and then you start making the models, and then bring them into a good correlation. So that is where there's a job opportunities for mechanical engineers to explore in BMS. What does an engineer student study in order to get into as a BMS hardware engineer? That's an interesting question. So if it's a BMS hardware engineering, right? So one, obviously, you could be good in the schematic development, right? So that's in general for all embedded hardware engineers. It's not like you could just see some circuits and you try to mimic them, but you could be having good amount of knowledge, good amount of project exposure to actually design circuits on your own. It may not be just a BMS, right? So it could be any circuits as well. So you should be very proficient in design, right? Uh, Basically design of schematics. Then if you have a knowledge of specifically to BMS, like how does it architecture of the components will be there, or if it is about something like selection of specific components for BMS application, right? So such kind of an exposure, if you have, how do you get it? You can build a lot of projects by yourself, and where you'll be able to learn how you can actually get an exposure on BMS. And then if you have a hands-on experience by working on some battery management system to know how do they connect, how do they interact, what are the kind of data comes in, what issues are there in the data, and where does it go, or where does it, what exactly the process of synthesis happens, or some analysis happens. So you kind of have an idea for that, then it's like more than sufficient for an entry level position. But if you'd like to explore something to become like a pro, right? So it's something like I recommend, like you spend a lot of time in actually designing more battery management system, gain like do some projects and stuff of it. I think that should be more than sufficient for you to kickstart as a engineer for the battery management system. Okay, I could see some more questions here. What software will be used in the industry as well as in learning level to design the BMS expect Arduino? Okay, so Arduino, yeah, I mean it's sort of a DIY thing, right? But definitely there's a lot of control boards from TI, NXP, Infineon, ST, and various other different suppliers. So definitely you can explore any of those toolboxes as well. what are the future projects related to BMS? So there are there's plenty of projects that you can explore, as a learner or as a student. But it's just quite important that you would just spend some time and really studying some very good important designs, and then you could uh, progress ahead for that. Cool. So any other questions from anyone? Great. So then let me just come back here and then share you some profiles for the second section of the course, where we'll talk about specific job roles and then what kind of requirements they have asked for. If we start from here, right? So responsible for develop application software, right? So BMS core algorithm development such as SOC, SOH, cell balancing, right? That's what I was talking about. There will be algorithms basically which are core of your application software, right? So that's where you write all your this algorithms in place. So then they are also asking you BMS software model based design using MATLAB, auto code generation, right? So like as I was telling you, nowadays nobody writes like 1,000 lines of codes. You could use like tools and then generate the programs. Then they're also asking you cell and battery and cell plant model development, right? And then they're also asking you accountable to perform all phases of software, hardware development. It's not something very feasible for somebody to know software also as an hardware. Sometimes industries does ask, but it's not like very important. But if you know both of them, and that's like the best of best. But if you have not of exposure to both software and hardware, but you could have one of it, that should be sufficient. Maybe this job role is like something like a team lead position, so they may be demanding somebody to have both the knowledge. Then also, if you come down on the side of it, so they're also asking you for a validation of algorithms, right? So as I was just telling you about, like you have to perform a lot of validations to ensure if your software is going to work in real time. And then you talk about all the level of testing, which could be using mill or SIL or hill kind of a testing. And typically they're using MATLAB for their applications, and then obviously embedded C, because it would be added advantage if you have the knowledge of embedded programming as well. So then they're asking for an embedded coder or a target link applications, right? So majorly, if you see this is a requirement, so they're trying to ask somebody to develop algorithms. They're trying to ask somebody to actually implement those algorithms and then to take care of validation as well. That's why this guy is a team lead, right? So with the bandwidth of 6 to 8 years of experience. But if you go down a little bit, something like 3 years to 4 years of experience, you may not have all the skill sets, but you could just possess these skill sets to a greater extent. Something like these algorithms, and then MATLAB, Simulink, code generation, and things like basics of testing and basics of validation. You should be really great at, more than sufficient for yourself to explore career as a software engineer, BMS algorithm engineer, right? So obviously these are the advantages if you can have embedded C and stuff like that. But yeah, it's good to have as a skill. So, but typically if you see that, to kind of overview through back again, so MATLAB and Simulink is a go-to toolbox. What companies have used, like Lucas has been using. Apart from that, the MATLAB, Simulink, then Stateflow. Then apart from these three toolboxes, we would use MATLAB embed, and then for the validation purpose also we use MATLAB in place. So if you kind of have these things and then put across your knowledge into a scale of programming, then you should be good enough for this kind of a job role, right? So like in similar, there are many other job roles which I was trying to go through, right? So good understanding of battery management system, SOC, SOH algorithm, cell balancing, debugging platforms, and validations and stuff in place. So if you see, it's typically a similar, a job profile, right? So it means to tell that that is what exactly is largely required. And apart from these things, I can also run you through some more job profiles that have been, I think this is a similar job profile. So if you go to something else on the areas of senior software engineer for the embedded of the BMS. So typically, if it is only an embedded right? People will not ask you BMS as a requirement, but if you would like to enter into core of BMS, then you need to know algorithms and developments and stuff like that. So there would be a requirement like an intern, right? So somebody from, what is this company called? I think, yeah, Rapti Energy. So they're putting it across, okay, you should have some knowledge of lithium chemistry of batteries and their application. They're asking for C++, ability to analyze electrical schematics and wiring. And this would be for an hardware, right? Not for the software development. So yeah, there are entry-level positions as an intern, but there are also entry-level position as a software engineer, or there could be a hardware engineer as well. So what a kind of overview at coming to a brief of the section is that you kind of have to possess certain skill sets, right? So that skill sets are basically the ones which will highlight your profile, and those profile will highlight you to basically kickstart your career as an engineer. So with all this journey, so how do you say that I would like to learn this, and then you would like to explore a job in battery management system engineering, right? So that's the question rises at everybody, that how do I build my career? So until now, this is the second phase of your webinar. So if you have any questions till now, so let's take those questions and bring up for the discussions. Anyone have any questions? All right. So let's say there's any questions right now. Cool. So if you would like to basically, let's say you're a fresh graduate and you want to start your career, or let's say you're a working professional and looking forward to shift your career. We see this people, like a lot of calls from a lot of people that they're working in powertrain on IC engine, like gasoline or a diesel, and then or maybe it's CNG and stuff like that. But now they want to move to BMS, right? A battery part of the systems in place. So our let's say there are fresh engineers, and they want to start their career in the battery management systems. So keeping this scenario, that's why we have brought the program at Decibels Lab. So this is a program where we are trying to teach you pretty much like in 2 years MTech degree, right? So but core focus to battery management system. This is a 9 months program and dedicated to battery management system alone. And this program talks about completely from scratch of understanding what is a cell, what are the materials of the cell, and what is electrochemistry, to a level where you could write algorithms, you can implement those algorithms, you can test those algorithms, and get a complete learning exposure to develop algorithms for BMS, a battery management system as an overall. And this course is for somebody who is not a student currently pursuing in his studies, but this course is for somebody who is having a basic exposure to batteries in their academics, like BE or an MTech level, but now they're graduated and they're looking forward to build their career, or somebody who might have even done a PhD and they want to seriously switch their career into industry, or somebody in an industry who is already working on some systems and now they see forward to switch over into a BMS systems. And that's whom the course is for. This is a dedicated 9 months program, which is 36 weeks and happens 65% online and 35% offline. And with this, this is with a placement guarantee, and where you could build a lot of algorithms for yourself. And the whole way this course starts is we would start the course with a expectation to help you to start your career as a BMS algorithm engineer, or testing and validation engineer, or a pack testing or seller pack testing engineer, or an application engineer, or a virtual validation engineer. So this is, as I said, it's a 9 months course which starts from the fundamentals of fundamentals, where you start with like understanding what is a cell, types of cells, the construction materials, the fundamentals of electrochemistry, to a level where you cut section a cell and you open a cell, start seeing the materials, start seeing the approach of manufacturing, And all these are the foundation skill sets. Then you slowly graduate to a next module where you start to learn about how do you actually test a cell practically? How do you observe its behavior as a cell? Because cell doesn't behave like linearly in all the conditions. Let's say if you draw more current, it behaves differently. If you conduct a test at a different temperature, it behaves differently. So like these things, the cell has a various operating characteristics, right? So you are to understand the characteristics of the cell. So that's the part of this module 2, where you actually perform a test. The decibels has the equipment which are shown here in the screen. So we can conduct experiments and then collect the data from the cell cyclers, right? So these data will be used for you to study that how does a cell behave, okay? So how does the cell function as as a chemistry? And then once you move ahead, you will be basically start working with real BMSs to understand what is their function and how do they collect the data, how does the control of the actuators will function, and how do you integrate a BMS to the real-time battery pack. So you will get onto a complete hands-on learning experience. The objective of this practically is to, or also to go through all the functionality of a battery management system, is to give you a profile, or help you to for a profile like requirement analysis engineer, right? So like let's say GM want to, or Mercedes want to develop a BMS. Most of the cases they won't develop the BMS, right? So they would send a requirement document to somebody like TCS or somebody like Infosys, so or like the other companies in place. So what do they do? There's a requirement engineer who kind of first sits and collects all the hundreds of requirements they have given, right? And then bring that into a project documentation or also a validation document. So the objective is to basically perform requirement analysis. So if you know how does a BMS function, how it is integrated, what kind of data are you expecting, what kind of performance activities you're expecting, if you know all of these things, it's easy for you to become a requirement engineer. So that's how you're trying to start with this on the module 3, and the module 4 jumps into real-time algorithm development using 1D simulation toolboxes, where you'll be actually building algorithms for SOC estimation, SOH estimation, and algorithms such as cell balancing. And you would learn how to actually model them at a fundamental level, and then progressively go ahead to build these real algorithms in the 1D simulation environment. Then once you build your 1D simulation environment, you have to perform testing. So we talk about a lot of testing and validation. It's virtual testing and virtual validation into place. And then progressively, we also teach you on how do you convert a model into a programming and a C code basically. And how do you put that programming into a real hardware, all right? That's the scope of it. And then we perform a lot of testing and to ensure that whatever we have actually put into a simulation or put into an algorithm is actually going to work in real-time condition. And then progressively, the decibels also cover some topics on AutoSAR compliances, and the compliance such as MISRA or ASIL compliances, or other objectives of project management such as DOORS or GitHub and stuff like that. This is an overall program that kind of prepares engineers to become industry ready or job ready in an overall scenario. So this is a whole 9 months program that could help you in building your career as a battery management system algorithm engineer. So any questions still here over to the audience? Let us know how we can help you in terms of queries in technical side, also on the non-technical side. I see some questions in the chat box. Is this course applicable for mechatronic engineers? Absolutely, it can be part of the. So you could definitely explore this course being a mechatronics engineer as well. Do you require any prior programming knowledge for this course? No, you actually not require any programming knowledge for this course. You could start from bare basics. Because you might have studied some basics of programming, but that should be sufficient to start with it. At present, is a selection process is going on? Yeah, that is true. So we have a selection process for the course in place. You would have to send your resume. There's a one-on-one interaction that happens with the participant, and then we finalize the participant in place. Well, any questions from anyone? All right, so we see another question. So can you please demonstrate one basic module on Simulink related to EV? Kunal, our team has done those sessions. I think they're available on YouTube, or those sessions are also available in the recorded lectures on our platform. Our team has actually created all these modules and done webinars in the past. So right now, I won't be able to demonstrate you right away. But yeah, those modules are also available on YouTube, and some of my colleagues have delivered those sessions as well in the past. Okay, any questions from anyone? Great. So by the way, good to see all of your interest yeah. Do you see you see a lot of interest from a lot of people to attend this and know about battery management systems? By the way, it's a great pleasure to see this, and we're very proud to say that we are one among the top in the country to offer some kind of a courses, some which are very unique in nature and which are very much focused to a laser focus to a specific industry profile in place. And it's not in just general, but these programs are highly customized and tailored for somebody to practically build their profile or their career in the algorithm industry of battery management systems. So if you still have any questions, so I'm over to you to check out and answer any of the questions. If not, Vinayak, you can also barge in here and give any inputs on the details. And if somebody is interested to pursue this course or for us to check if this course is suitable for you, you can also go to this link and you could basically fill out the Google form. We have the inquiry form here. You can just book your slot here. Okay, it leads to you to go to a Google form. There you will be able to actually fill out your information, and one of our team members will get in touch with you to help you for the purpose of giving you clarity of the program as well. Well, any questions from anyone at this moment? Right. So if somebody is not so much serious about planning their career with a dedicated program like 9 months, and somebody's trying to explore that whether it suits me, whether it interests me and stuff like that, you can go to the Decibels courses on micro specialization courses. And these courses are also very well brought by a lot of industry people in place. I'm going to send you a link here. This course is like the BMS algorithm development is somewhere about 300 to 400 hours of course, right? The short-term certification courses are somewhere between 30 to 40 hours in length, right? So that's the overall way how the short-term certification courses. The objective is to basically give you an idea on what is BMS, how does it work. You can build some of the algorithms as well to begin ahead with. But the master course is a highly dedicated program which talks about complete end-to-end product development of algorithm development cycle. So any questions from anyone to finally discuss with me on the queries here? All right, so I see one question. So do you charge for 9 months of the course? Yes, absolutely. That's how the module is currently available. We don't have I can take this module or I can break this up. This course is basically costing about, this is the overall fee that is for the course, which is mentioned here, which is about 1.8 lakh inclusive of taxes. So if you are a working professional, the course fee will be 1 lakh plus the taxes. This is for the participants who would like to also get a complete job assistance from Decibels Lab side. I can also see another question that where do we can send your resumes for the selection? Others, please go to this section of our website. You can book your slot. Our team member will get in touch with you and they will further explain the process of it. Yeah, but right now you could just go and book this slot to get a call back from our side to help you out. Great. Any questions from anyone? I don't see any questions right now at this moment. So Vinayak, I think you could barge in to kind of give us the instruction on how do you generate certificates, how do you take ahead the further learning path for the students. Over to you.
Thank you so much. Hello guys, good evening. I'll just show you the how you have to generate your certificate. Just give me a moment.
Vinayak, you're able to share your screen and show it across?
Yeah, I'm sharing the screen.
Right. So, by the way, the instructions provided by Vinayak to help you in generating the certificates for this webinar in place. So, over to you, Vinayak.
Yeah, thank you. Good evening, everyone. Once again, I have pasted the link in the chat box. You can open that. You'll land up here in this particular web page. You just have to enroll free. You have to click there. You have to log in from the same mail ID you have registered for this webinar. Like for example, I'll go log in with the Google. You just have to select your email ID, registered email ID. You'll land up here. You can go through the content here, and then you have to click complete and continue. There'll be a small feedback here. You can give your feedback so that we can improve or you can change anything. We can do that. In future, I'll just type a test here for showing your focus. Then let hit continue. And then click continue, complete and continue. Then you will get a link here, get your certificate. You have to click on that. Your certificate will be generated similar to this. You can either download it as a PDF, you can copy paste the link somewhere. You can share it on Twitter, Facebook, and LinkedIn. Please, if you post it on your any social media, please tag us so that we can reshare that. Any questions related to generating the certificates, you can put it in the chat box. Yeah. Thank you, Pankaj.
Yeah. Good to see all of your interest for participating in the session. Kindly share your feedbacks in the chat box. How was the session and was it useful? Were you able to take away something from this session as a learning?
Yeah, I'm sending the feedback form. Just a second.